one-to-one example. So this function is one-to-one on its domain. Which is everything but 1, right? I can't have 1 in there. So negative infinity to 1, 1 to infinity. There's a break at 1. Right? And keep in mind my asymptotic behavior, right? We practice these. I've got an asymptote at 1 and I've got an asymptote. So x equals 1 is an asymptote. And we'll get there when we go to graph, but y equals 3 is an asymptote. Alright, so to find its inverse, I know it's 1 to 1. So first thing you do is replace y with my function. So y equals 3x minus 1. Then we flip what x and y do. So there are two x values, so you've got to make both of those y. So you got x equals 3y over 3 minus 1. 3y minus 1. And so this one makes it a little harder because, and it is, the algebra on this one's a lot tougher, but once you've seen it, it should make it a little easier. There's a trick to the algebra, right? Because I've got two y values. And so my first thing is, well, to get rid of the fraction, I'm going to multiply both sides by that bottom y minus 1. And so distribute my x here, those reduce. On this side, I'm left with 3y. Over here, I'm left with x times y minus x. And then what you're going to do, this is the tricky part. You're going to move the y terms to one side. So I'm going to subtract that negative xy. So I get negative x equals 3y minus x times y. And so that's the reason why we do this. This next step was the trick. I can't combine those, but I can pull the y out. I can factor it. I can pull y out, and that's going to leave me with 3 minus x on this side times y. Negative x is on that side, and then once I've factored it, I've got a multiplication. Well, to undo a multiplication, you divide. That reduces to just y, and on this side I'm left with negative x, 3 minus x, and there is my inverse. Right, which you will notice the domain of the inverse is everything but 3. Right, x cannot be 3. So it's negative infinity to 3, 3 to infinity. So bear that in mind when we go to graph our functions. Right, the hard part about this is graphing, but you have a graphing tool, graphing calculator. You should be able to graph them using your tool. All right, so there's my original function. And then its inverse I'm going to write up here, which we found was negative x over 3 minus x. Alright, so the graph of this is tricky, but again, I encourage you to go ahead and use your calculator to get the picture, and remember what you learned in Chapter 4. Alright, so first thing I'm going to graph is the f of x function, and I'm going to graph it in blue. And the first thing I'm going to do is I'm going to mark off its asymptote. It's got two asymptotes. I'm going to kind of write that information down here. So for f of x, it's got a vertical asymptote, at x equals 1, and a horizontal asymptote at y equals 3, right? It's got the same degree in the numerator as the denominator. The leading coefficient is 3 divided by 1. And so that's the first thing I'm going to do is I'm going to mark off those. So vertical asymptote at 1, so dotted line. So there is the x equals 1 asymptote, and then 3. There's my y equals 3. All right, then I'm going to plot a few points, and you can use your calculator to help you out with these points. So I'm going to plot one on each side. So if you look at the calculator, part of it's up here, and the other part's down here. All right, so first of all, if you plug in 0, you get 0 out, so it does go through 0, 0. And then if I pick a point on this side, I don't know, I might pick negative 2, negative 2, negative 2, positive 2, so one point on my curve is negative 2, 2. Right, that's on this side, so if I draw the shape that my calculator is showing me, it approaches my asymptotes, and so there's the 1/2 of it. And then the other half, I'm going to pick something on that side, so I'm probably going to pick, let's just do 2 to be consistent. So I did 2 and negative 2, so if I plug 2 into this equation, so again, I'm looking at this one, if I plug 2 in, I get 6 out. 1, 2, 3, 4, 5, 6. Oh, here we go. And so there's 2, 6. And again, if you look at your calculator, it is up here. And it approaches my asymptotes. Alright, so the blue line is f of x. So f of x is the blue function. Its domain is everything but at -1, or not -1, +1. And you'll see its range is everything but y equals 3. Alright, so keep that in mind. Alright, the second function, f of x. I'm going to graph this one in red. So again, same idea, it's got asymptotes. So first of all, it has a vertical asymptote at x equals 3, and it should make sense. X and y is flipped, and so the asymptote behavior should flip. So this one had a y equals 3 asymptote, so it should make sense. It's reciprocal, should have the opposite, x equals 3. And so it has an asymptote at x equals 3. Right, so it's got a dotted line here. At x equals 3 is its asymptote. And it's got a horizontal asymptote. Well, its leading coefficients, right, would be the negative x and the negative x. Well, negative x divided by negative x is a positive 1. And so it's got a vertical asymptote at y. And it should make sense that it's y equals 1 because its reciprocal, or inverse, was x equals 1. And so it should make sense that that's the case. And so in red, I'm going to draw that dotted line here. At y equals 1, right, is the reciprocal function. And now graphing it, and I should check that the points flip. And so it should be the opposite of 2, 6, so I'm going to plug 6 in, which means I should get 2 out. And so if I do plug 6 into, again, this function is what I'm plugging 6 into, I do get 2 out. So 1, 2, 3, 1, 2, 3, 4, 5, 6, I get 2 out, and so there's the point. 6, 2. And if you look at your calculator, it's between the red asymptotes. So I kind of drew my point where I'm going to graph it. So it comes down on this side and comes up on this side. So again, that was the point 6, 2, which again, it reflects. Now I'm going to plug in, again, it's the opposite, so I'm going to plug in 2. If I plug 2 in, I should get -2 out, and I do. If I plug 2 in, I do get -2 out. Right, and so again, and it goes through 0, 0. Right, if I plug 0 in, I get 0 out. And so remember, it's approaching the x-axis, x asymptote, so it's going through and then down. Oops. And so that point was to -2, and it checked, right? The points flip on me. So the red is the first, so the red is the inverse function. There we go. I can't spit it out, apparently. I can't talk today. And f of x, the blue function, is the original. And you'll see the asymptotes flipped. Okay, so I'm going to kind of write out all these sort of important graphical important parts. The asymptotes flip. Domain and ranges flip. Alright, so for the original function, I'm going to write it in blue. Which I kind of already had here, but I'm going to rewrite it again. Alright, so the original function f of x had a vertical asymptote at x equals 0, x equals 1, horizontal asymptote at y equals 3. Its domain was -infinity to 1, 1 to infinity. Its range exists everywhere, but remember, it doesn't cross the y equals 3, so every y value except 3, so -infinity to 3, 3 to infinity. Alright, now the inverse function should be the exact opposite of that, and it is. The inverse has a vertical asymptote at x equals 3, right? Horizontal asymptote at y equals 1, and right, my x and y values flip. That's what I literally did to find it, so it should make sense that the asymptotes flip. Domain of the inverse function was -infinity to 3, 3 to infinity. Its range, if you look at it, its domain existed everywhere but at 3, and its range exists everywhere but the y value 1, right? Because the y value 1 has an asymptote it never crosses. And so its range is -infinity to 1, 1 to infinity, and it does hold true for the inverse behavior, right? So it holds true when we graph it. Now this one, like I said, we sort of graduated, right? We start with an easy case, which was just a linear, Cubics aren't that bad either, and then when we get to something like this rational case, it's a little tougher, especially the algebra, but it all kind of checks out. Alright, we will stop there. So that's the last of the cases that are one-to-one. In the next case, they're not going to be one-to-one, but we're going to restrict the domain and force them to be one-to-one. Alright, we'll stop there.